we are going to be going over the AP PreCalc Unit 6 practice test. So, we're going to go over question 1. The radius of a circle shown is 5 inches. Find the length of the arc B to C. Okay. Now we know this is 2.5 radians. Now, the main thing that we're going to need on this problem is to know that, wait, I need a pen. One moment. Is that radians and radius are the same. So radius being from A to C or A to B is equal to radians. Because the radius or the radians are based on the radius. And what I'm saying is, let's say our radius given our circle is 5. That 1 radian would be an arc length of 5. So if we estimated this line on this, it would be right around here. So, back to our question, 2.5 radians. Well, 2.5 radians, that's bad, radians would also mean that it has to be 2.5 times the radius. Do it like that. So 2.5 times radians is equal to 2.5 times the radius. And if we know that the radius is 5 inches, well, it's going to be 2.5 times 5. And then that would be 12.5, which is D. Now, if our radius was different, for example, 3. Our radius is 3. If we keep the same angle, well, it would be 2.5 times the radius. Our new radius is 3. So it would be 2.5 times 3, which would be 7.5. Yeah, 7.5. The same would be if you change this, right? If you said 3 radians, and then you had a radius of 3, what would be 3 times 3, which would be 9. So you would have an arc length of 9. And that would be in pi. Or not pi. That would be in inches. So those were both examples, and that was the answer. Now, for question 2. 2 periods of a periodic function y equals g of x are shown. Find g of 81. Now, this is personal preference, but what I like to do is I like to zero it out. And what I mean by that is have one of the points cross 0, 0, or anything on the y-axis. So what I mean by that is if I were to shift all of this over 2, I would shift this graph 2, but that also means I shift this point over 2. So now this point becomes 81 plus 2, or 83. So now, if I were to kind of show this, we would start right here. We'd have the small, the big, and the small, and the big, right? Something like that. And we'd continue on. So this point would be at 0, 0 now. This point, if we add 2, it would be at 12. So 12, 0. So first, to find our period, this being 0, 0, and this being 12, 0. Well, we know our period is 12, right? Because this to this is just 12. So 12 period. Now, to find g of our new number as 83, well, if we know it repeats every 12, then we can do 83 minus something close to 83. So 12 times what is close to 83? Well, that's 6. So 6, then we put our period length So we have 83 minus 6 times 12. This is 72, and this is 83. We minus, that's 11. So we're going to count over 11 from here. So it would be right at, give or take, that point. And if we look back on the graph, it would be right there. And if we count up 1, 2, 3, 4, 5, our y would be 5. Another way to solve this one is just to forget about the plus 2 and just find the period and do the same thing, but you'd be counting from here again. So it's a little different, but that's just the way I like to do it, so everything is simpler for me. Now, the next one. Angle theta is shown in standard position with terminal rate passing blah, 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 right? So what we're going to focus on is find this, okay? So find the sine of 2 pi minus theta, theta being this. Now, what do we know? We know that any positive angle is going to be going counterclockwise. So if we draw a circle, positives are going to go counterclockwise. Negatives are going to go clockwise. Now that's going to be a little important for us. So we have 2 pi minus theta. Well, 2 pi, if we start here, would be a full rotation, so we end up back here. Now, this negative, well, that's going to go backwards. So we're going to be going like this, and then doubling back. Another way to think about this is basically, we take this angle, and we're just going to rotate it. So it keeps its distance from these 2 points, but we're just going to rotate, instead of being from here, we're going to make this one, the x value. Now, when we do that, we're basically just subtracting this from 0. So it's subtracting this angle from 0 minus. So we're going to be going backwards, like I said. And if we shift this down, the x's are going to stay the same because it's the same thing, but it's just negative. So we're going to have the line go, give or take, right around there. The x values stay the same, like I said, so it'll be 0.42 given up here. But our y's are going to change. It'll be negative 0.91. And that is